For question 1, part A, we have a double header sort of inequality. A couple of different options here, which I'll try and show you. The first is that we deal with them as separate inequalities and then combine the results at the end. And the second is that we try and deal with all three parts at once. To begin with, I'll show you the separate method. So here are my two separate inequalities. I'm going to solve them both. To make life a bit easier, make a positive amount of x. Notice I'm keeping it less than or equal rather than forgetting and going to less than. And again, I'm going to make a positive amount of x. So x is going to be greater than 0, but also less than or equal to 1, so I can then combine my results into a single inequality. Alternative method here was to try and deal with all sides at once. So I can subtract, again I'm trying to isolate the x in the middle, so I'm going to subtract 8 from all three parts of this inequality. And I'm going to divide 3 by minus 3, but remember, when we divide or times by a negative number in an inequality, that changes the signs of the inequality. So divide by minus 3 gives me this, which is the same inequality as I got the first time, albeit it's written the other way around. Part B, we've got a classic quadratic inequality. The way I've always taught this to you is, first of all, get 0 on one side. Then I'm going to solve it as an equation to find my critical points. Then I'm going to draw a sketch of the inequality. So this inequality here, I'm going to draw a sketch of the quadratic. The only important thing here is the shape. So it's a positive quadratic, and then the x-intercepts, which we know are -1/2 and 3. And then I go back to the inequality and I say, well, I want it to be less than or equal to 0. So that means that I want the bits that are beneath the x-axis. So that's these bits here, and that means that these x values along here, so everywhere between -1/2 and 3, so -1/2 less than or equal to x, less than or equal to 3, again less than or equal to, because my original inequality was not a strict inequality, it had an equal sign there as well.